Okay, so part A gives you f of x, and it wants you to find the slope of the line tangent to the graph of f at x equals pi. So find the slope of the line tangent to the graph of f. So what are we going to do to f to find the slope? I hope that you're saying derivative. So we're going to take derivative of f. So remember, the derivative of cosine is negative sine u du, which is going to be a 2, so I'm going to stick that in front. Okay. And then we've got plus e to the u du, right? So that's e to the u du, and the derivative of that is cosine. I'm going to just stick that in front. And we need to evaluate this at x equals pi, which, remember, that's just 180 degrees. So negative 2 times the sine of, well, we've got 2 pi here, so that's really 360 degrees, right? Plus the cosine of 180 times e to the sine of 180. All right, so the sine of 2 pi, what is the sine of 2 pi, everybody? It's 0. So that would be 0 right there, plus the cosine of pi, that's negative 1. And this is e to the, and the sine of pi is 0. So we really have 0 minus, and e to the 0 is just 1, right? So that's 0 minus 1. So we can say that f prime of pi is negative 1. So part B asks us to find k prime of pi, but I think what I'm going to do first is just find k prime. So here's my k right here, and that's going to require me to do a little bit of chain rule. So the derivative of h would be h prime of f of x, and then take the derivative of the inside, right, which would be f prime of x. All right, so now what we're going to do is we are going to plug in pi. Remember that that's 180. So h prime of f of pi, and then we're going to multiply that by f prime of pi. All right, so let's look up here at the top. We know that we have f of x, so we can find f, oops, make that look like an f, f of pi. So we're going to take the cosine of 2 pi, and we're going to add to that e to the sine of pi. All right, so I want to take a minute and figure that out. You can pause me. Okay, so the cosine of 2 pi is 1, and e to the sine of pi, well, the sine of pi is 0, so that's e to the 0, and anything to the 0 power is just 1, so f of pi is 2. So then when I'm looking down here, I can replace this value then with 2. And then I'm just going to bring down my h prime. And now f prime of pi, well, over here I have f prime, so I can put in a pi in for these x values and figure out what f prime is. Oh, well, wait a minute. Let me take that back. Didn't we do that in part A? So in part A, we determined it was negative 1, didn't we? So I'm just going to go like this because these guys have to stay together. And I know that f prime of pi from my part A answer is negative 1. Okay. All right, so how am I going to find h prime of 2? Well, I purposely cut and pasted this picture up here because this is h. So what is h prime in relationship to h? It's the derivative, right? So this is the derivative at 2. So here's 2. What's the derivative? Isn't that the same thing as slope? So find the slope of this line, and you'll have your answer. Okay, so the slope of that line is negative 1 over 3 and then times that -1. So the final answer is 1/3. So part C, I'm going to start by just taking the derivative. I'm just going to kind of leave the 2 out of it for right now. So let's take the derivative of m of x. I'm going to have to do product rule there. So I am going to, if you want to look at it from this perspective, these are your 2 products. So the derivative of g would be g prime of the inside, and then don't forget to take the derivative of that, which would be -2, which I'm going to stick in front there. Okay, so that's the first derivative times h of x. Plus, now let me take the derivative of that second, which would be h prime of x. And then that's going to be times g of -2x. Okay, so now I'm going to plug in my 2. So I'm going to get -2 times g prime of -4 times h of 2 plus h prime of 2 times g of -4. So let's keep going with this. So I've got -2. Now I want to find g prime of -4. Look up there. See what you get. What's g prime of -4? So here's g prime. There's -4. So it's -1. So we've got -1 here. And then I want h of 2. Well, you have a graph, and this is the graph of h. So how would you find h of 2? And if you look at this, here's the x value of 2. So I basically want to know what this y value is. Okay, now let's look at this, though, because I'm going down 1 and over 1, 2, 3 to get to the next pretty point. So that means each time I'm going down and over, down and over, down and over, I'm going down in thirds. 1, 2, 3. Okay, 1, 2, 3. So then I know at x equals +2, this would be -2/3. So let's put in -2/3 here. Plus h prime of 2. Well, we had h prime of 2 in part B, but you could look, remember how we find h prime? If we have the graph of h, what do we look for? We just look for the slope at 2, and that slope is -1/3. G of -4, you can look at that in the chart, and what is that? That's 5, right? All right, so the rest we're going to just work it out. So these guys right here, I end up with -4/3, and these guys right here, I end up with -5/3. So that makes that -9/3, right? Which is -3. So that is what m prime of 2 is equal to. All right, so if you read part D, to me, this reeks of the mean value theorem because, number 1, it's talking about a number C. That's your first hint. They're giving you a closed interval. There's your second hint. Then they're talking about g prime of C. There's your third hint. Okay, so let's see if you remember the mean value theorem. So remember, mean value theorem is, in this case I'll use G, but it could be any letter, G of B minus G of A over B minus A equals G prime of C. Now that's just the general formula. Now we're going to plug in our B and our A. So your B, remember, that's your B, and that's your A. So we're going to do G of -3 minus G of -5 over -3 minus -5. All right, so we're just going to work this out, and let's see if we end up getting -4. Okay, so, well, you can look all this up. You can pause me, work this out, see what you get. So I have 2 minus 10 over 2, which, bing, 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 is a -4. So I know that G prime of C equals -4. Ooh, look at that. Oops. So it's G. Sorry, I'm trying to make up for lost time here. Okay, so let me give you the written explanation. Okay, and so here's the written explanation that goes along with the mean value theorem. So we would say yes. And again, because G prime of C here equals -4, and so does this. So that's why we're saying yes. Because G of X is differentiable. Now it's differentiable because at this point C, we have a value. So that's what makes it differentiable. Now remember, if a function's differentiable, that means then it has to be continuous. Okay, and then there's going to be at least one value of C that's between the interval given. Remember, we don't include the endpoints, though, in our definition, where the derivative is equal to -4. Now, if you go back and you look up the mean value theorem when we did this, that's kind of what we said. Okay?